having got your research through the IRB, then it's going to go to a study section somewhere, perhaps the NIH or other place, and who knows what will happen to it there. Well, actually, we have 3 people who do have some insight as to what will happen to it when it gets to study section, because they've all sat on numerous study sections. So we have John Christman, who is the director of the Critical Care Center and Division Chair of the Pulmonary Allergy, Critical Care, and Sleep Medicine Division of the Department of Internal Medicine, and a researcher in lung inflammation and pulmonary host defense. We have Chandan Sen, who's a professor in the Department of Surgery and the director of the Innovation Program for the CCTS, and does research in tissue injury. And we have Cynthia Carnes, who is the Associate Dean for Graduate Studies and Research in the College of Pharmacy, also the co-director of the CCTS KL2 program, and does research focused on cardiac arrhythmias. So you might each mention some of the study sections you've served on, and then just let you proceed and just talk about your insights about the good, the bad, and the ugly you've encountered in study sections, both on the behalf of the people submitting things and maybe even the behavior of the people on the study sections. But whatever tips that might help people to get their projects funded.
Okay, I'll start. I've been a standing member of ESTA, which is the Electrical Signaling, Ion Transport, and Arrhythmia Study Section, affiliated with NHLBI. I've also done a lot of ad hocs for, I'm doing a score review next month, programs, awards, et cetera, et cetera. Okay,
I'm Chandan Sen. I have served in multiple study sections related to vascular biology, tissue repair, surgical. I've served as the chair of surgery, anesthesia, trauma study section for 1 term. And after you serve as a chair, you get to go out and then not serve for that many number of years. So I'm in that phase. But in that phase, you think you would be not so busy, but actually it's more busy, because now I get to sit on most of the special emphasis panels where that reviews the grant of people that sit on the study sections. So it's the process continues, and right now I'm reviewing a P50 and all different mechanisms of review. Yeah, John.
I'm John Christman, so I'm a physician scientist, and I've actually had a funded lab since 1984. And have published about 150 papers, mostly related to sort of pre-transcriptional regulation and epigenetic regulation of macrophage gene expression in inflammation, both asthmatic and acute lung injury. So I have been on a lot of study sections. In fact, right now I have a continuing submission privilege because I was on 6 of them in an 18-month period of time. It's sort of like I'm collecting them. So I was on the SAT study section for quite some time. LIRR, LCMI, I've been on the T32 training grant study section, lots of ad hocs and things like that. I'm also review grants for the Bavarian Science Foundation, the Italian Cystic Fibrosis Foundation. So I really have a lot of experience with grant submissions. You know, we'll go back and forth, but I thought maybe I could just start off and tell you what the criterion is. So let's just assume that you want to submit a R01, an independent R01. Everybody needs to know there's actually 7 criterion that are looked at by the reviewers. There's some other criterion that are not scorable, like budget. You know, your budget might be talked about, but it's after the scoring is done. So significance is one of the most important thing, and I usually define that as significance to human health. Could be scientifically significant, but for the NIH, it's usually significance to human health. Innovation. Now, this is actually a little bit difficult, but they want you to be innovative and use state-of-the-art methodologies. Sometimes that requires developing, so there can be technical innovation, there can be scientific innovation. There's lots of ways to define innovation, but that's one of the criterion. Approach, you know, what are you going to actually do? And that's where the supportive data comes in. New investigators are not really required to have a lot of supportive data, but the longer you've gone out and not gotten funding, the more it's expected to. So if you're coming right out of a PhD program, maybe you don't really need too much at all, but if you've been around for 3 or 4 or 5 or 6 years, the more you're out, the more that's expected. And it's suspected to be high quality and novel. Then institutional support, from your department chair, your institution, they want you to know you're at a good place. If you're at a small university that's not a research university, there's actually a special category for that, and you go to a different study section and it's studied. I did that once also. And then the investigator, they want to look at your track record. So who did you train with? Did you train with somebody on the National Academy and had excellent training? Did you go to a good school? If those kind of things. But also your publication record. If you have no publications ever, that's not going to bode very well. And then the two new ones are sex as a biological variable. So the NIH really expects you to look at gender difference. So if you're studying mice, you keep the male-female separately, and there may be a different related to sex as a biological variable. And then the last thing, which is also new, and all the study section members are looking at very carefully, is this validation of your data. How do you verify it? How do you make sure that the antibody you have purchased from somewhere really is measuring what you think it is on your Western blot? I mean, are you cutting it out and sequencing it, doing a Sanger reaction? I mean, they're really serious. How good is your data? How reproducible? What's your study design? Those kind of things. And you really need a pretty extensive section on that thing. So those are things to keep in mind, because all of these have a purpose, and you need to take every section seriously.
Yeah, I'll just continue with what John said, and then I'll flip over to what I look for when I'm reviewing a grant, and then perhaps we could have a good discussion. I think on the new stuff that started from 2016, the only thing that was left out is scientific premise. So now there is, in significance, they're required to put a scientific premise. And where does the field stand? And so a succinct statement based on references, so on and so forth. So do underline the scientific premise piece in significance. That's a must do. And by the way, we covered all the new requirements in a separate video by the CCTS put out a few months ago. So it's posted in the web. I just checked before coming here. So if you're trying to look into how to tackle the new requirements, there's a separate video that covers that. Coming back to this discussion, I think, who is applying? The bias sketch is very important. To put together the bias sketch in a hastily manner at the last moment is a bad idea. The personal statement must really have some thought put into it, because many reviewers, including me, carefully read it to see where you're coming from and where you're going with your career. So that's a very important piece, and you may even have some mentors read it and provide some feedback. It's not like a small paragraph that you'll write it and it carries a lot of weight, in my opinion. As John pointed out, productivity is key. So if there is a great proposal that you have, I've often advised, while mentoring people, hold off in submitting the proposal until you generate a bias sketch that shows some recent productivity. You have a great proposal, and all of a sudden, last 5 years, last 3 years, you've been completely silent. That's a big no-no. And you have these 2 papers sitting in your desk for a long time. Pause on the proposal, get those papers out, get something hit on the radar so people get a little bit more comfortable with you, and then come up with the science. A few additional remarks, and then I think Cynthia, and then hopefully we'll have some good back and forth discussion. See, data, especially for a early stage investigator, I'm assuming many of you didn't write many grants, I'm assuming this is an early stage investigator scenario. You're not required to put in a lot of data, but whatever data you put in is subject to scrutiny. So just to casually throw in some data without really giving the experimental context, the procedure, the methodology used, a reviewer is going to find it very difficult to interpret what you're saying, and it may actually come back against you than in your favor. It's okay to have fewer figures, but whatever figure you have, that, it's very clearly as to how it was done, what really, and then that you're open to interpretations. So preliminary data are not supposed to be, firmly concluding. So if you can use those data sets to open up new questions and be available to the suggestion that there could be an alternative interpretation of the same data. That type of flexibility is very important. It scores well. I think I'll pause there, and then we'll continue. Yeah.
Okay, so I'll just follow up on the preliminary data, because that seems to be an area where I see a lot of missteps. What I like, and one thing I tell people is when I'm reading grants, I just carry them with me, and wherever I am, if I have a few minutes, I'll pull it out and read. I'm not going to sit down and read your grant from the first page to the last page in sequence. So what you want to do with your data figures is make sure there's a title. I can glance very quickly at the figure. I know what happened. I can sort of pick the thread up. Lots of times what I see is people will just stick them in there. They may not have the axes labeled. They may not have a title. You're looking at it, and you're hoping it has some relationship to the text around it, but maybe it's not so clear. It may be very clear to you because you're very familiar with it. You need to have somebody who doesn't really know your proposal look at it and make sure they can follow exactly what point you're trying to make. And tell the reviewer what the point is that you're trying to make. This suggests, as Chandan said, that this alternative hypothesis maybe so. Whatever the point is that you're trying to make, tell the reviewer what the point is. I always say it's better, and I think we heard this on the IRB, it's better to make things as easy as possible for the reviewers. One other comment I want to make on the biosketch is if you have a deviation from normal productivity for some reason, don't think that the reviewers aren't going to notice that you had a big gap. If there's a reasonable explanation for a variance, put it into your personal statement. I always like to see that. I don't know, I'd be curious to hear what other people think. But instead of me just having a question in my mind, I think we're all people, and people are sympathetic if you have a good explanation. But don't think it's going to go unnoticed.
I think just along those lines very quickly, also that, when the certain clinical specialties, when you join those, you clearly don't have time for research, although you would love to. And there's 3-4 year, silence, so to speak. If you explain it properly, and then if you have a letter of support from an appropriate person, say your chair or whatever, I think most of the time people want to give you a grant. It is when, they feel uncomfortable, that's when they pull out. So the basic mindset is, if the early stage, how can we help them out? You just have to help the reviewer to build a case.
Yeah, or a major medical issue, or you wanted to be home with your kids for a couple of years until they were a little older. All of that stuff, life goes on for all of us, and I think reviewers are very understanding. But when there's gaps there, then they just assume you just didn't publish, and there's not a good reason for it. So I think that's a real important point. A couple of random things that I would like to say. I've reviewed a lot of grants for young investigators, and I try to put a lot of red ink on them and be as critical as I can be. But the biggest problem I've seen is that you don't get it done quick enough. You really need to get your grants written 3 months early. And I know that sounds like a lot of time, like a lot of people only start writing them 1 month early, but it takes a long time. It always takes me at least 2 months to write a grant, and that's if I don't, have anybody really else look at it. And that's not so good for me either. I mean, 3 months early and hand it to several people, that will really look at it. And they can be non-scientists, too. If you happen to be lucky enough to have a spouse who is an English major, that's a good idea. My first mentor, Jean Ronaldo, actually had been an English teacher before she went to medical school and got into science. And that was really good for me. But get it done early and get a lot of people to look at it. And I would say across the board, make every change that somebody suggests in that. And you'll end up with a much better product at the end. A lot of times we're so close to the science, we miss the obvious things. And sometimes it's a little more confusing in our heads than it is, than we think it is. Hypothesis-generated research is better for junior investigators. The NIH has trained the reviewers to to consider hypothesis-independent research that uses technology to generate hypothesis or so-called hypothesis generating, but it just doesn't play well with junior investigators, not that well with senior investigators either. That's the kind of thing you need to get your CTSA to pay for and get that data, go forward from, not included as something. I would say if you're missing something scientifically, engage an expert. I just wrote a grant, and there was some of the molecular biology, was a little tough to me, and I tracked down a very senior investigator in the backwoods of Norway who wrote a nice letter saying it would help me with the studies, which was really nice of him. I don't know if it'll work, but I'm going to be at one of those special emphasis panels in December 6th. I would say avoid a lot of reproduction. Say things once and well, but make sure everything's consistent. Don't change your specific aims from the first page to when you're actually describing them. It's easy to make a good idea look bad, but it's not so. You can't possibly make a bad idea look good. So you got to have a good idea, and you want to make it look good. The three other little things to say is, and I think this kind of came up, and they may disagree with me, but preliminary data, I always call it supportive data. And data, to me, is irrefutable. If it's too preliminary, it may not be correct. Now, data is what it is. If you're not sure of that data, you shouldn't put it there. And if you are sure about it, you shouldn't try to verify it in specific aim 1 by doing it over or doing it more repeats. So whatever you put in there, high quality, and make sure it's take it to the bank information. One of the things that I hear very often by reviewers is, well, specific aim 1 is just basically repeating their preliminary data. They must not be certain of their data. And that's a very important thing. Also, specific aim 1 and 2, I like 2 specific aims. A lot of people like 3. I don't know exactly how you can get 3 in a 12-page thing, so 2 is easier to do. But they shouldn't be dependent on each other, because someone will say, well, if 1's not true, 2's not worth doing, and vice versa. And I think that's kind of important. And every specific aim ought to be 2 or 3 papers. The reviewer ought to be able to look at it and think, this is 2 or 3 publications, this specific aim. I mean, you're writing a 5-year grant. If you're not getting 2 or 3 publications out of every specific aim, then maybe it ought to be a one-year grant. People have already talked about certain things, but I just want to mention them again. One thing that's very irritating to me, and it kind of irritates me to the point that I hate it, is when people use acronyms and I don't know what they are. And that seems to be an Ohio thing here too, by the way. And one thing you can do is define it on page 1, define it in page 2, define it in the approach. If you want to use an acronym that's not that standard, have another page with all the acronyms on it. But I really hate, I've gone back and haven't been able to figure things out, and I've had to look them up on Wikipedia to try to figure out what an acronym is, and then sometimes it's just the best guess one, and that's really hard. So write it all out. You're not going to be saving a lot of a space anyway by acronyms that are non-standardized. And then density is a big issue. You don't have to fill up every space. Reading things is very difficult. A study section, keep in mind that for a study section, a full load is 10 grants. So I might have 10 grants. I may be the first reviewer on 4 of them. Maybe 3 of them I'm a second reviewer, and maybe I'm a reader or a third reviewer. But everybody's expected to write, the full amount. I know some of the times the third reviewer will just write a little goofy paragraph that says nothing, which is kind of irritating. But the NIH encourages 3 to write as much as 1. Now, 1, of course, sets your score, and that's an important thing. It might be worthwhile to tell them exactly how these study sections work, so they get an idea of who gets triaged and who doesn't. I'll let you do that.
I'll quickly.
This is brutal.
So when the proposals come in, there are things that happen at the back end even before a study section meets. A chair is expected to go through all and expected to also go through the score sheet, because after so many hours before the study section, the website is closed. And if there are really big differences, I've had instances where the chair and the program starts talking about how to handle those, and some of them get, somebody gave you a 2, a 1, and then you have a 7. And I was trying to make an unsaid rule that if one reviewer's score is worse than the sum of the 2 other reviewers, then there should be, some type of discussion, because otherwise any one reviewer can pull the average down to below discussion. So the way it goes is it used to be 50%, and then it was moved to 40%. So regardless of the numerical number, score, you essentially draw a line for where the 50% is, and essentially the remainder does not get. There is an effort in some cases to discuss more of the early stage investigators, and the way we currently were doing it is when we go through the order, the best score gets discussed first, but even before the first best score gets discussed, we discuss the ESIs, the early stage investigators. So you guys are discussed, when everything is really fresh. And there is some hesitation to triage, and actually I've had people that rescue people, ESIs, below the 50% line quite often. And it's a matter of, how you, build the case. And I think I'll let Cynthia say a little more about that. But one other thing that may be considered is, when you're writing this first grant, and you have all this data, you have all this excitement, it's very important to understand that you may have 6, 7 key findings, figure out what to write a grant on, and you have to triage some and put them out of the grant. You cannot have multiple foci of so-called excellence in the same grant, because people are getting now all puzzled. There has to be this one center of attraction. And if you have also other things, maybe you should consider writing another grant. But to package them into one grant and try to get the feeling that maybe they'll be impressed the more data they see, that's clearly, that doesn't work. So Cynthia, back to the triage process, yeah.
So what happens is you'll look at the scores beforehand, the top half get discussed, the bottom half do not, unless somebody goes through and says, I still want to talk about it, even though the score was low. So in that example, if I got a 1, a 2, and a 7, presumably the person who gave it the 1 would be like, absolutely, I want to talk about it. Unless they were completely convinced by the person who gave the 7 by reading theirs that, wow, I missed this fatal flaw. Usually nobody would ever admit to that anyway. So that's the process. The other thing to keep in mind is the first reviewer who sets the score, as Dr. Christman said, has to be able to provide a summary of your project in about 3 minutes. You don't want to make your topic so complicated, so many foci, so much data, so many extraneous ideas, that it can't be easily digested and discussed or described by the primary reviewer in 3 minutes. So it's good to not make things too complicated. You want to make it as complex as it needs to be, but don't make it overly
and that 3 minutes
complicated.
includes, if that's a K award, who you are and your career development plan and your science. So clearly there must be a very pointed message that should emerge from it. If there is a very convoluted message, it's going to get lost. Yeah.
Questions?
We could battle for quite some time.
Yes, please.
So for like a junior physician scientist starting in a faculty job, should they go for the K award first, or should they save everything and work on an R01?
So I think the broader question here, I think that's a very good question, but the broader question here is how to pick what mechanism of grant to apply to. And then the more pointed question here is that should you go for a K award or should you write an R01? And much depends on your training background. For several clinicians, KO8 pathway is recommended. For many of them, they already have a PhD, they have numerous publications, and then people start actually wondering, why do they need any more a K? They should directly come to a R. I think, first of all, it's very important to have a mentorship group that actually is helping out with these answers. Secondly, I think this is a very good time to start discussing with the program director also. They're very open to you, especially if you're an early stage investigator. Start talking, and you will learn so many things, and the more perspectives you get, the better. And eventually, it depends on where your biosketch is now. And based on that, decisions are made. John?
MD, a physician scientist or a PhD scientist? Yeah, I think a K is worth a lot of, it's worth the gold for your career. I mean, the NIH has plenty of data that the K to R is the most successful pathway. So if you do clinical research, it'd be a K23. If you do more basic research, it's K08. And if you're lucky enough to be an underrepresented American, you can do a K01. But K is clearly the way to go. If you're a PhD scientist and you've been in a good, successful postdoc and you're moving into that same area, then a kangaroo grant or a KOO, ROO, what is it?
K99 ROO.
K99, RO1, whatever.
RO0.
I call them kangaroo grants. And what that is, it's a K for the first few years, mentored, but it goes to independence. So by the end of it, it's an RO1. So I think that's the most successful route. The K99s are underutilized, and if you're eligible to put one in, you should if you have a PhD. Physician scientists can put those in also. So let's say you're a MD, PhD, or you've had a little extra research, or you got a good idea, or you finished a T32 or a F32, then maybe a K99 RO for a physician scientist.
So one word of caution that may be helpful, which is when you have mentors, it's very important that you not be viewed as an extension of that mentor. Critically important. If people think that you are doing the same enzyme or the same protein or the same pathway and one variation of it, that's not a good launch of career. So you want to use all the strengths of that laboratory, but you want to ask a question that clearly sets yourself different from what was the theme of your mentor. And this issue comes up often.
Yeah, it's a good idea to pick a mentor that's not a one-idea mentor. Because sometimes, especially PhDs, they'll work with somebody, and then at the end of that time, they really expect you to leave that work there and go do something else in a different field. And, that breaks what I call the thread of continuity of research. It's a good idea to start something and make it get bigger and develop a platform and move forward. But if you're interrupted and you have to start a new area of science, that's a pretty big barrier for you. So you want a lab that's big enough that can launch, that has enough ideas and enough science in it that it can launch a new investigator. You want ownership of something in there, even if you're working on your PI's RO1. If the PI has complete ownership of this, then that's what I would not call that's what I call a malevolent mentor, not a benevolent mentor, and you really need the latter. Somebody will share with you and launch your career, not somebody who's gonna basically use you as a work unit to promulgate their own science.
I have 2 words of advice. I completely agree. I think that's something, a discussion that it's good to have with your mentor early. If you're starting out, lots of times I see people leave that discussion too late. So it's good to have that discussion early when you're starting, what's the line of research, and at some point I'm going to move on, and what's that going to look like? It's good to, that's where things can get ugly sometimes.
And what helps there is, many a times that I have seen, and there could be other opinions, is to really have a committee that smoothens out, as opposed to you trying to tackle a gigantic person who has this influence, and just have a committee, and it will even out some of those rough edges, and they will be able to find yourself an environment which is for you, because you only get one chance to launch yourself as an ESI, and if you do it the wrong way, I think that's a major barrier that you cannot overcome later on. Yeah.
So you guys probably realize there's new investigators, NI. You can be a new investigator, but not an ESI. ESI is within a certain period of time to your terminal degree.
First 10 years.
And you get extra points as an ESI. So where funding might be at a 16th percentile for an experienced investigator like Chandan Sen, you get 26%. And only 5 of it is free. And then the other 5, usually you have to respond to the reviewers and send it. But it's not sent out to those same reviewers. It's looked at internally at the NIH. And if you respond pretty well to it, you'll get that extra 5 points and you'll be funded. And that means, a push on your tenure track.
And some institutes slash centers at the NIH are more sensitive to ESI. I just met yesterday somebody who got an 8th percentile and was not funded as ESI and had to revise. And so that shocked me. I mean, I've never heard of the other institutes. And so I think it's good to talk to the program directors, do some due diligence in figuring out what's a more a friendly institute for you, and then do all that homework before you submit the grant.
Yeah, I noticed on the website right now, when you get a grant that's not funded, it's got a little link on what to do next. And since I just had one grant that wasn't funded, I actually hit that to figure out, well, what am I going to do now? It's actually pretty good, but the main thing is you want to discuss with your program officer. You'd like that program officer to really engage with you and give you some ideas. They won't guarantee funding, and they really don't do anything that biases it in your favor, but they can give you some really good advice. And get to know your program officer by name and call them up and go to Washington, D.C. and meet them in their office if you need to. But engage them because they want to help you. They want you to be funded because if you're funded, that means they've got a secure job and it's a government job. It comes with a good pension and,
And they also show up in major conferences. So if you make a point and write, Dr. X, are you coming to this conference, the major conference, they'll show up and you can actually get a time to sit down with them face to face. And they're actually more free at those locations than they are in their own home building.
Yeah, but if you dial that number that's listed as them, they answer. There are no secretaries at the NIH. They answer, and they'll talk to you and get back to you about it. They're very reliable and extremely helpful.
Our one last thing is, and I think this was passed over briefly, and I just got this question with respect to the CCTS KL2 from somebody. To me, the important thing is if you're trying to figure out where you are, if you need a robust training plan, which is a big part of the K score, then the K is probably the right mechanism. If you're pretty far along, you may be too mature for a K. It's not a good use of your time to spend a lot of time on a case. So really think about, is there a specific career development, because that's an important part of the score, that I'm going to derive from going through this training program. And think about, and that's where talking to your mentoring committee, what are the things they see that you need to get you forward to where you'll be ready for an R.
And sometimes Ks are also awarded for switching your line of investigation. So you may have been a health outcomes researcher, and now you want to get more involved in, molecular genetics and related to public health or something, and there are career switching Ks. So that too can be used.
The other thing is, I don't think it's ever too early to put a grant in. If you're always waiting for your magnum opus or to get another piece of data or whatever, life moves pretty fast at a fast pace. And if you get to be 2 or 3 or 4 years out, it gets harder and harder. So as early as you can actually get a grant in. So, let's say somebody had a T32. Who's got the T32? You should be writing an F32 right now. F32 and T32 are identical in funding, so you might think why. But an F32 requires you to write down what you're doing, and it's a 6-page format. And if you don't get it, you're still funded. But if you do get it, you now have an individual grant, which makes it better to get a. And if you can't write it, then maybe your project's not formulated clear enough.
Yeah. And having said that, also ask, do not submit a sloppy grant. People remember you. People remember your institution. It's not like, people remember you. They have amazing memories for stuff that was not so nice. So you put all your effort, because that grant is your identity to your peers. That's a business card to your peers. So put all the effort in, take time out, make it look nice, get input, and then submit.
Yeah, I would just to share I have reviewed a lot of K awards and things like that, and I watch people's careers over time. Now some have been very successful people, 5, 10, 15, and even 20 years out. And I kind of think of myself as their secret Santa. I kind of launched their career, and I feel somehow connected to them because you learn a lot about someone's personality when you read their grant. It's a pretty intimate exposure of your thinking, your thought process, and all of those kind of things. So I feel like I'm friends. So years later, I'll go up and I'll remember everything that they wrote a decade earlier, which is kind of cool.
And you ask this mentee, why did you submit this if you were so unhappy? No, in my milestone with the chair, there was a deliverable that I had to submit within this quarter a grant. If you are stuck in a situation like that where you feel the grant is not ready, and you're turning it in because there is some pressure on you, just get help. Get some mentors to talk to your chair. That is not how you are supposed to be submitting a grant, because you can also hurt yourself and your future chances by putting in the wrong document.
We have time for another question.
Okay, we're not leaving until we get 2 more questions.
So well funded.
Who will stand forward?
Are you guys, somebody just talked about private research funding, being that NIH grant funding is variable with the current political landscape?
Put in every possible grant you possibly can. So in my field, I'm having people putting ALA, American Lung Association, American Thoracic Society, Parker B. Francis Awards. Megan Ballinger in my division came from Michigan, where they also basically put in every possible grant, but no one there had put in SDG grant to the American Heart Association, because we're lung doctors, but it turned out Lung 1 and Lung 2 of the AHA funds an awful lot, and she now is the proud recipient of an STG grant, which is like getting a K award, and will help her move towards a tenure track position. And she would have never have thought of it if I hadn't mentioned it.
And those also help your R01 cases. Clearly, they are, they decorate your biosketch and show that you have gone through a peer review process where other people have laid their confidence in you. So clearly, those are also important. It's not, really the aspiration that first step must be an R01.
Yeah, the NIH says that those are highly predictive of success in a career. You got to meet a deadline. You have to have a coherent grant. Lots of things. Plus, all of you aren't going to write 5 different grants. You'll write that same grant 5 different times until you finally get it. And it takes about, these guys might refute this, but my informal tally is it takes 6 submissions and 5 failures before you get one.
I'd go with that.
Persistent.
But that being said, because I also review for the American Heart Association, sometimes also people take an R01 that didn't fund, and they'll try to cram the exact same grant. Sometimes I'll be on both study sections into an AHA submission for a fraction of the budget. Those always get slaughtered. If you're going to go for different mechanisms, make sure the grant matches the budget and the scope of work that seems reasonable. Otherwise, it just looks ridiculous, overambitious.
Well, thank you, panel, for a very stimulating discussion. And thank you all for attending, and we wish you good luck in your research endeavors.
Good.